Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. We also have a special guest, Gary McCready from HVAC Know It All. How you doing, Gary?
I'm doing well tonight. How you guys doing?
We're doing all right. Kev, how you doing this week, man?
Freezing cold.
I was going to say, how cold is it up there in Chicagoland?
It was -2 this morning in the city on the roof at 4:30.
Nice. What are you working on this week, man?
Doing Danfoss changeovers. So I'm so thrilled.
He's been dealing with a headache for the past just 2 days, but he's been loving every minute of it.
What do you Danfoss what? Switching over what, Kevin?
We're going from like old 1992 RMCCs to basically Danfoss 800 days.
So RMCCs, Gary, just so you're aware, are basically older CPC controllers, and then he's switching over to something that kind of looks like this.
Okay. And that is to control what exactly? Is that to control an entire system, part of a system?
Yeah, it basically controls everything in the entire store. So it controls everything from the compressors, the fans, to the some of them, the heat, the cooling, controls basically everything. It's like the whole like brains of the store. It's basically running an IO network, meaning like it has separate boards that it's slave commanding to do whatever task it needs, whether it be defrost, refrigeration, whether it be turning fans on and off.
Are you doing the lights and shit? Are you doing the lights and all the HVAC with the Danfoss?
Yes, unfortunately.
Wow. So we used to do controls too, like at the company I used to work at. That was reliable controls. It wasn't refrigeration though. It was for basically HVAC stuff. But we wouldn't get into controlling lights. So you guys are controlling lights in the supermarket as well with that stuff.
Yeah. Typically the way it works is we control it over two methods, right? We'll have a set schedule. So let's just say the lights are scheduled to turn off at, I don't know, if like 7 a.m., but there'll also be a backup in there where it'll go off a photocell. So if the photocell senses a certain foot candles, it'll actually shut off the lights before the time. And the same thing with it turning on the lights. Like the light schedule might be on, we're going to turn it on at 5 o'clock or 6 o'clock, but then we're both those statements have to be true. So the schedule has to be true, but also the cut out for the light or the cut on for the lights also has to be on. So like once it gets down to about, what do we usually set them for? 20, 25 foot candles, Kev?
Yeah, about that.
For a cutout. So basically when it gets, when it gets that dark, because when you have if you shine a light on a photocell, it'll show freaking 800 foot candles, right? Like if you just take a flashlight to it, but if you cover it up with a piece of tape, it should go back down to 0. But usually about 20 to 25 foot candles is usually where we knock shit off or turn the lights back on. I'm sorry.
Yeah. So this is way more in depth than I would ever get into refrigeration because I don't do supermarket racks, none of that. I've done pharmaceutical stuff, smaller applications, and the biggest controller I've seen, or the most complicated one I've worked with, is the Honeywell T775, which I like, but I mean that's to the extent of controls that I get into with refrigeration. So this is crazy.
Wait a minute, is that big gray box with the red screen and has a couple buttons?
Yeah. Yeah.
Okay.
Yeah.
We deal with them on the blood banks.
Yeah, you can control boilers with those, pretty much anything you want, but there's been a lot of pharmaceutical applications where they've chose to throw those onto into the control box type thing, right?
Yeah, and that's what Kevin basically does. He's that and a firefighter, right?
Yeah, I guess I would like this store to catch on fire.
I'm sure we've all got customers we feel that way about, Kevin.
Oh, this may be like one of the worst stores we have.
They're having Gary. They're having to put on VFD drives on condensers that are how old, Kev?
Not at this store, but there was another store where it was almost 30 years old. There's one of them I think that's going to get stopped. But this store, we're doing drives at this store, and their sprinklers are on at 50 degrees.
That's awesome.
Do you mind if I ask you? Do you mind if I ask you guys something along the lines of low temp refrigeration?
Sure.
So This is pertaining to heat, superheat, because Brett, you brought up superheat earlier when we were talking before you hit record, and some of the stuff I used to take care of was, would you consider minus 40 degrees Celsius low temperature application?
Is
So
Yes.
minus 40 C and F line up together, so it doesn't really matter.
So here's the weird thing. So if you look at a Sporlan power head chart, right? Negative 40, I think, is the end mark for a Z charge.
Mm-hmm.
You know, because you have different charges, right? You have the C is commercial, which is I think 50 to negative 10. Then you have GA, which is general application, which is like, you know, chillers and air conditioners and shit like that. Then you have Z charge, which is 0 to negative 40. But then you have X charge, which is extremely low charge, which goes from negative 50 to 100. So it's like kind of borderline, like what it's actually considered. But I mean, typically, like on the blood banks and stuff that I've serviced, they usually typically have Z charges on there, so it's considered just regular low temp.
Yeah, and this was blood plasma that they were storing in
Mhm.
these freezers, right?
Mhm.
And it was for pharmaceutical purposes. And what I wanted to ask you about was the superheat that you would see at the compressor on a system that runs that low, that low of a box temperature. Because there was a couple I would work on that were side by side on the roof, and when they were working normally, we were getting anywhere between 60, 65 degrees of superheat at the compressor from like all the way up the piping outside a bit and right at the compressor. And these things would run, they would cycle, they would hit set point. Are you
Mhm.
guys seeing high superheats on low temperature applications with longer pipe runs like that?
How long are you talking?
I'm talking like 50, 60 feet, maybe, maybe 75 feet.
Kev, what do you think, man? Because usually on low temp, it's weird. So like on any low temp thing, I usually say see 3 to 5. But like if you talk to some of the guys that run the blood banks, they'll say that they want like a 6 to 8 degree of superheat, which, you know, I mean, if you're getting 65 back at the pump, dude, I'd think that your insulation is messed up, or your superheat is way too high. What do you think, Kev?
I mean, to get 65
At
degrees,
at the compressor, not evaporator, at the
yeah,
compressor itself. Yeah.
even that, like, I mean, 60 feet of line's not that much. So I mean, it shouldn't heat up that much unless the Armo is just like completely toasted.
Yeah.
Yeah, I don't like. I mean, we work on you know, bakery boxes that are all the way in the hell in front,
Hmm.
right? That are, you know, like 200, 250 feet away, and you know, you set that thing to 3 to 5 degrees of superheat, you're getting, you know, maybe 10, maybe 15 degrees back at the rack.
Yeah.
So I don't. That seems awful high.
Yeah. Well, they were running. Both of them were set up the exact same way, and they both ran by the, like, they were redundant systems, right? It was one box, two systems redundant of each other. Either one could run and maintain the box, and both were running the exact same way. And for maybe, I left the company back in May, but maybe for 10 years at that point.
Yeah.
Yeah.
Huh. I mean, that just seems awfully high. You know what I mean?
No, it's high to me too. Very high
Because,
to me.
well, typically, like what, you know, Copeland. If you look at a Copeland guide, depending on what compressor you're looking at, typically you have 20 degrees of superheat at the compressor, right? That's minimum. That's to
Mhm.
make sure you don't, you know, get any flood back, you know, going to that compressor, any rich kind of superheat. And then there's usually a max temperature of 65. You know what I mean? So like on air, think about air conditioning, right? That's something you're real comfortable with. So you typically run anywhere from a 38 to a 40 degree saturated, right?
Mhm.
And if you get 20 degrees on top of that, you're
Mhm.
looking at 60 degrees, right? Which is about what your suction line temperature is going to be at your condensing unit, right?
Mhm.
So even at a real high load where it's real hot that day, you might have like 42 or 43, which still brings you underneath that 65-degree line temperature coming back. Because otherwise, you're going to work outside the operating envelope, and that compressor is going to overheat, and either the module is going to open up in the compressor or the three-phase is going to grenade.
Oh, yeah, I totally agree, but I just found it bizarre. Both of these systems ran that way, and they ran like this for years. The suction line was still ice up. I mean, we were running at, I think it was 404A, and we were running at Geez, I don't have a PT chart in front of me, but I mean, we're running down at like 6-7 psi on the suction side,
which is like negative 40.
Mm-hmm.
It's like right about negative 40. So if you're running 32 degrees, I mean that's 72 degrees of superheat, right? Like because ice, you know, you have to, in order to have ice, it has to be at 32 degrees, right?
Yeah, that's right. Yeah.
I bet you that Armoflex is just like full of water and ice, and it's
it could be you might be right on that, Kevin. It might be just filled with a lot of water, because as it was going up, once in a while they complain about drips coming down below the piping, and there was no way to get at it unless you got a specialized genie boom in there, because it was going up against the back of a bunch of boxes that were lined up together, and there was really no way to get back up there without a special genie boom. But since it was running, it was maintaining, all the alarms were kept in check, it wasn't really an issue for the facility at that point. But I just thought it was interesting. And these compressors were scrolls, and they were outfitted with liquid injection. There was like a mechanical. It was a mechanical device, right? And it had like there was a well in the compressor, and there was a temperature probe that went into the well, connected to a mechanical device that would liquid inject into the scroll compressor.
Yep.
Yeah.
Those are called a DTC valve, discharge temperature control, I think maybe what it's called. But essentially on that particular one that you're talking about, that goes directly in the top of the head. You have to be really careful with those, because a lot of times, you know, people will change compressors. They'll grab them on with a channel locks or whatever. When they do that, they basically crush the bulb. If they crush the bulb, what's going to happen? It's going to push that valve a little bit farther open, right? And then cause that thing to feed when it's not supposed to. And then it ends up grenading the compressor, because the thing thinks it's hot, but it's not. And then you're just basically forcing that valve open. So if there is any liquid in that line, it's literally turning it on a liquid start.
Yeah. No, good point. No, very good point. So that's really my extent of refrigeration, is small pharmaceutical applications that stored. I mean, you could have a walk-in box that was 20 by 15 or 15 by 10 or something small, and you could have $5 million worth of product in there. So, and these things weren't the equipment wasn't very big, right? We're talking about small equipment here to keep these things cool, because we're not talking a large amount of product. We're just talking about very expensive product. So it was really weird living. It was kind of like being in the supermarket realm a little bit, but we didn't get nearly as many calls as a supermarket would, because I have a friend in the supermarket, and every time he's on call, he's gone all weekend, every single time.
Kev, you run service only when it gets slow, right?
Well, I mean, pretty much every day after I'm done with my 8 hours, I pretty much run service.
Yeah.
So I mean, yeah, I mean, there's always calls. I mean, I think we're backlogged for like 2 months probably, and it's almost February.
The parts thing is killing us. Like, as far as getting calls closed and stuff like that, I don't know. I mean, you do predominantly residential, correct? Residential and light commercial, correct, yeah?
I've been doing a lot of residential lately, just because I started my own one-man show, and that's where the cash flow is right now.
Yeah.
But I've been teetering between residential and commercial over the last 8 months or so.
Gotcha.
And yeah, the parts thing has gotten everybody. I think the supply chain has failed a lot of people, and it's just something we have to deal with. There's a lot of room for universal type parts these days, or aftermarket parts if they're available to use, because the OEM hasn't. Like Carrier, for example, there's some parts for Carrier rooftop equipment that's been on back order for over a year, right? Like, what do you do? What do you do at that point if the part has actually failed? I mean, you have to come up with some other way to provide the customer with some sort of air, whether it's heating or cooling, right? It doesn't matter what part of the industry you're in. If you're missing a part in refrigeration for a rack or a grocery store, and that OEM's on back order, what do you do? Like, how do you guys deal with that? I should ask you that question.
I mean, a lot of MacGyvering and hoarding. a lot of hoarding. Like, I mean, my entire office is full of like spare parts and used parts, and stuff we take off. It's like, that's good. I'm going to keep it. Like there's a lot of that. I mean, other than that, like we have just gotten absolutely hosed by like the supply chain stuff, like for like construction stuff, cases. I mean, there's times where we're waiting weeks for cases to show up. They're supposed to show up. They don't show up. Well, now it's costing us a ton of money. And then when they do show up, it's like, now they're overlapping 4 other jobs. And now we're again.
Well, not just that, Kev. Well, you told me like there was stuff coming in without stuff. Like,
oh yeah, like cases half put together, racks with components missing. Like, I'm waiting on VFDs for a store we finished a year ago still.
Wow.
The evaporator
has shipped them twice now, the wrong voltage.
Evaporators coming in without actual fans or fan guards.
Yeah.
So they'll hang them, right? Because they, the construction job has a certain set that has to go first, right?
Yeah.
Box gets built, coils get hung, then they get piped. Shit gets piped, shit's all ready to go. It's like, well, can't start it up. Well, why not? No fan blades. Well, why not? They're on back order. What do you do?
Yeah. So so do they give you guys a heads up that it's coming with no fan blades, or does it just show up that way?
90% of the time it just shows up that way. Like,
Yeah.
no warning. It's just like, we better not tell them because they're gonna get mad.
Tell them. Didn't you say there was a fucking IOU on it?
There's IOU inside all these cases, like IOU 64 shelf clips, like this. I'm like, it's like this controller. It's okay.
At least with like residential, I don't think you get any condensing units that, hey, we're missing a board, we'll get you back next week.
Man, the IOU thing you just hit home with me on that. When I was a kid and I used to get paychecks, I'm going to tell you, this is not work related at all, but it was just funny. I forgot my check and I was going out with my buddies and I forgot my check at home. And I used to put it in the bank machine and then it would spit the cash out after. So I wrote an IOU for the amount of my check on the paper and I put it into the bank and I took the money out anyway. Right. It was, they went on a trust level back then. And my bank account got suspended for like a week after that. So don't do that, folks.
That sounds like a Canadian thing.
Yeah.
They're gonna trust you for a week.
Yeah, well, I mean, hey, I was gonna put the money in when I got my check but I needed the money right there and then. Anyway.
Yeah.
It's pretty bad. Like, I mean, missing parts, wrong parts, half put together parts, components, just missing components, half-assed components. I mean, everything's gotten cheaper too.
The longevity of some of the equipment is just not there anymore. And like, and a lot of it's if you really think about it, it's the Department of Energy, because they'll put stipulations. Like, so I know you guys are probably definitely dealing with this up there in Canada, where it's, they say it has to be, you has to save this much energy, right? Mm-hmm. So they'll oversize units, and then they'll run the head pressure all the way down, and then basically the condenser is now, the compressor is way oversized, so it brings the suction pressure all the way down. And then it ends up causing failures because the suction pressure is too low. And it's an ongoing cycle. Well, it's supposed to run. Well, it's oversized now. So you have to kind of manipulate the in order to get it to function right.
Interesting.
It's a numbers game. It's because if you think about it, if you have a condensing unit that's running at 120 degrees saturated, right? And you jump that thing down where you lower the head pressure all the way down to 75 degrees saturated, that compressor now has increased capacity by anywhere from 25 to 35%. Okay. Mm-hmm. So now that compressor is way bigger. So what's going to happen to your suction pressure?
Are you asking me?
Yeah, I'm asking you.
So, sorry. I didn't know you were asking me. Sorry.
No, you're fine. You're fine.
No. Go on. Explain, because I'm just absorbing this.
No, you're fine. So if you have a compressor that's bigger than what it's supposed to be, what's going to happen? Your suction pressure is going to be lower, right? Mm-hmm. And unfortunately, the way things are sized, right? They usually go off the TD, the temperature difference between the saturated versus your discharge temperature. So most of the time when engineers size shit, they'll size it for a 10-degree TD. So what'll happen is, if it's sized for a 10-degree TD and it's a 1-ton coil, you're going to need a 1-ton evaporator. But now if we're running a bigger compressor where our suction pressure is going to be lower, Now our compressor is way bigger, which means our suction pressure is lower, which means now our TD is higher. Well, when you increase the TD, so if you go from 10 degrees to 20 degrees, now the actual evaporator coil is not sized for a 1 ton. Now it's actually sized for a 2 ton. So, we have units out there that are supposed to be running, a 6 to 8 degrees of superheat, but they can't do it because the TD is so high. So now the evaporator looks way fucking bigger. But the expansion valve stays the same size. So you're running like 30 degrees of superheat on something that's supposed to be running 6 to 8 just because of the way the engineering rolls. So if you were to example, like in residential, if you were not running a 38 degree saturated coil, right, you run it all the way down to fucking 20 degrees. That coil is now increased size. So technically you would need a bigger piston or bigger expansion valve. And so what happens is you end up causing, ice ups and shit like that. And now you have to explain to the customer why this doesn't work. And sometimes it's just like, hey, that's the way it was designed, and there's nothing I can do about it, where they should have did something to control the suction pressure or have some sort of, vapor injection to raise the pressure, because otherwise it's not going to function right.
Now you're saying the suction in this scenario, the suction pressure is lowered. Now, is that causing any problems with your oil return? Or are you no?
You're still getting the same pull.
Okay.
You're still getting the same pull. You're still, you're still actually in all reality, you're getting a higher velocity. And a lot of the systems we work on have oil separators anyway.
I was going to ask you that as well. Would it matter since you've got an oil separator on the system anyway?
Yeah, for the moment, yeah, you're still running the same velocity, if not even a little bit more. And as long as you have, because there's 3 types of separators that we deal with: helical, coalescing, and impingement screen. And the only one that's really volume based is the centrifugal. So as long as you have like a coalescing or a impingement screen, it should separate it no matter what velocity that you pull at. Typically, Kev, do you ever see any fucking helical or centrifugals on the single units at all?
Some like really, really small separators, I think, are.
Yeah.
I mean,
So
I hardly ever see separators on single units. It's pretty rare. Like maybe a plasma center or like something like that. Like, I mean, I hardly ever see single units with oil separators unless it's like something really big.
Yeah. See, the problem is with centrifugals, you have to run a certain volume. So I know Kev's had calls. I know I have, where we have oil failures constantly on the rack. And what happened was it didn't happen until they removed they took 40,000 BTUs off and put it on a new rack somewhere else.
Mm-hmm.
So now you're running 40,000 BTUs less. Now you got 5 compressors, but only like 1.5 are running. Like one is running all the time.
Yeah.
And then you have the other one running on either on a VFD or a digital. And if it's not running a certain amount of discharge CFM, it's not going to separate that fucking oil. So then the oil just basically passes through and goes down the line. And then all of a sudden, now you lost all your oil from the rack. All the compressors start going off on low oil. And then all the oil is out in the fucking system because the separator wasn't doing its job. The rack was intended for, a certain amount of discharge CFM. If you don't have that discharge CFM, it's going to tell you to go fuck yourself and not separate properly.
Yeah. See, this is the kind of stuff that I am totally unaware of in the world that you guys are in. I wouldn't know it's got an oil separator. Like, why isn't it separating the oil? I wouldn't know that running at a lower capacity at 1.5 compressors instead of 5 would cause that. I wouldn't know that.
On a centrifugal, yes. On a impingement screen, not so much.
Okay.
Kev, what some of the things that you've seen with the impingement screen? What are some of the things that cause the failure for that not to separate?
I mean, whether the screen blows out, usually like 90% of the time, it's the screen blows out. So there's looks like a screen door screen in there and a cone. It's shaped like a cone, and basically what happens if a compressor breaks or pieces of valve plate break off and go through there, it slices through it like a knife. So once it cuts through the screen door, just like a dog running through a screen door, I mean, there's a giant hole now, and then everything's going through the hole instead of through the screen. So it causes it to separate. So like 90% of the time when I see that, it's a torn screen.
Yeah. And how often would that happen?
I mean, it depends. I mean, if they have a lot of compressor losses, it's pretty common. But usually, I mean, that those separators are getting ripped out, and they're either putting a centrifugal or a coalescent style in because they're just so much more efficient. I mean, the old style separators are only like 60 to 70% efficient. So, I mean, they don't do as good a job of separating oil as a coalescent or a helicoil do.
Yeah, coalescing. So I like coalescing the best only because, basically, if the unit is sized, if the separator is sized for 35 discharge CFM, you could run all the way down to 2 discharge CFM, and it would still fucking separate. Okay, but if you have a centrifugal, if you have size for 35 discharge CFM, and you're running, what is it, 25% less, Kev? Usually, like 25% less, and after that, it barely separates shit.
Yeah, but I will say this: if you overload a filtered separator, a coalescent, it will not separate worth a shit.
Yeah, so there's a fine line that you have to play, and unfortunately, like a lot of engineers, like they'll take a rack and they're like, yeah, we can throw another 60 on there, but they won't do anything with the separator or they won't do anything with the condenser, So
Most of the time, what I see on startup is it's all sized for max ambient. Well, everything in Chicago is sized for 110 degrees now. Well, we run that for 5 days. So you're designing equipment to run at 5 days of runtime when the whole rest of the year is going to see 50 to 70 to 80 degrees, and now we're like way oversized. So, I mean, that's where like all those issues come in. I see.
yeah, and like it's weird, Gary, because like so there is a difference between discharge CFM and suction CFM. So when we're programming a controller, right, to tell because we have to tell the controller what size compressor it is, because the algorithm basically decides like, okay, so which compressor we're going to turn on based off how fast the suction pressure came up from set point, right? So if it came up super fast, I might turn on 20 horse. If it came up a little fast, maybe I kick on a 10 horse, right? And then so that's the suction suction CFM. But then the discharge CFM is off a totally different number. So it's actually off of, oh fuck, now it's gonna make me look like an asshole because I can't remember. Is it the difference, Kev? Is it the difference between the suction and the discharge? And there's like some kind of chart that you have to follow to basically follow the discharge CFM.
Correct.
Okay.
And then, I mean, Westermeyer makes that sweet app that does it all for you.
Thank you, Westermeyer.
You just put all your parameters in there, and it'll tell you what your discharge CFM and what your actual suction CFM are based on all your loads and everything in your design parameters, and it'll let you pick what separator it thinks, and it'll give you a list of alternative separators.
Yeah, so there's actually a part in there that you can actually set it up for like refrigeration. Like refrigeration, you're using this separator for refrigeration, and it'll basically give you a range of what you want, because they know you're not going to run full load, full balls to the wall every single freaking time, right? So they're figuring out. That's why like a lot of the remodels like that we see, Kev especially, because he does a shit ton of them. Sometimes they'll take a centrifugal separator and they'll downsize it because they know that basically whip it around that refrigerant at that certain velocity. Like the original what you were telling me what the fucking lines were, Kev. What were they? What were they originally and what they tuned it down to?
A bunch of 2 5/8 discharge lines. I think the rack had like 4 compressors, 4 big boat anchor 060s on it. And we changed a bunch of cases out, added some glass doors, took some load off, shifted some load from rack to rack. And then we ended up dropping the oil separator from 2 5/8 down to 1 1/8.
Think about it. It's like a fucking garden hose, right?
And then back up to 2 5/8 going out to
I feel like I'm on planet Pluto right now. Because the way you guys are talking, this is not the lingo that I use. Like I've never heard CFM used to talk about refrigerant in a pipe. I've never heard that until this conversation. Is that normal in rack refrigeration using CFM?
A lot of times, yeah.
Really?
I mean, a lot of components are sized off CFM. Like when we're like doing control wise, like we're controlling like the capacity of the rack. I mean, you could do horsepower, you could do BTUs, but like more than likely the best control you're going to get is using CFM.
And how do you calculate that? How do you calculate CFM in a discharge line or a suction line?
Well, I mean, if you look at the compressor, like if you use like the Copeland mobile app, it'll actually tell you what CFM the compressor is, because all the controllers that we deal with, they when making their decisions, they deal better with bigger numbers, right? So you could do, oh, it's a fucking 40, it's a 20 horsepower, right? Well, if you give it a bigger number, the algorithm actually works a little bit better and controls a little bit better, and then it just makes better decisions based off of the bigger numbers that it can calculate with.
Mm-hmm. So we're on the oil separator thing. It's been a while since I even looked inside of an oil separator, but there's one that has the basically the float inside, right?
Well, so I mean,
all three have a float. So
all three have a float. Okay.
All three can have a float. So
okay,
there's what they call impingement style, and then there's centrifugal, which is like a screw, and then there's coalescent, which is a filtered that separates the oil. Now they could all have what they call reservoir. So they could all have a reservoir at the bottom and no filter, or sorry, no float, and the oil just comes straight out of there and goes to a electronic oil float that on the compressors that feeds in. We would call that a high pressure oil system. Now, every time you see a float, generally that's a low pressure oil system, so it's draining that oil into another vessel.
So it really depends on what the oil system is, right? So typical oil pots or oil, and I know fucking Jordan Schimmel's gonna make fun of me for saying this, but oil pot or oil level control, which is usually stuck on the side of the compressor, those are only allowed to have, the Sporlan ones are only allowed to have a 90-pound differential from oil pressure to actual suction pressure, because otherwise it'll end up breaking the damn float. Okay, but a lot of our compressors now have the OMB, the OMC control, where they, it's a ported oil level control. So basically, it meters the amount of oil going in there a little bit slower. So there's no mechanical parts to actually break. It's essentially just a fucking solenoid. So it just opens up full bore and it just lets that oil go through. And that's the reason why we need either high pressure systems or or low pressure systems. It depends on what the customer wants. Right. Yeah. I mean, when we say centrifugal, when we say helical, when we say impingement screen, when we say, coalescer, that's just the method that it's using to fucking break the oil away from the refrigerant. Right.
I see. Okay. Gotcha.
If you have a float, now you have to basically lower that pressure, because what's going to happen is the oil float's going to level up and there's no reservoir on there. So you need some kind of holding tank, so, somewhere to go there. But there are some separators that are, what we call turbo sheds, which have a reservoir in the fucking separator. So there's no need to have a float. And then at that point, it would just typically go discharge pressure right in the compressor and, be modulated by the OMB or the OMC, essentially the electronic control. You've probably seen them in the plasma centers for sure.
No, these are smaller type machines, man. These were like little condensing units. They weren't nothing major.
Okay.
Or maybe on some of the, maybe someone, yeah, you might be right. Like they just almost look like a hermetically sealed canister, kind of.
Mm-hmm.
Yeah. Okay.
Yeah. No, for sure. And then it has a little 3/8 line. Sometimes instead they'll have like a little capillary tube that just turns on all the time. Like it'll have a solenoid in there and just puts.
Yeah. I'm as you're talking, I'm just kind of thinking back to that one I was telling you with the high superheat, and it did have it did something similar to that. I believe it had a solenoid in line with it.
Yes. Yeah. So whenever the compressor comes on, it just automatically fucking goes full bore, right?
Yeah.
Yeah. So
yeah, interesting. So let me ask you this then. If you have a failure with your oil separator and the oil gets logged into the evapes, how are you guys bringing the oil back safely back to the compressor without drying the compressor out or bringing too much back at once?
Well, Kev, you want to answer this? How you bring the oil back if the separator is not separating the way it should?
Well, the easiest way is to shut the rack down for like a half hour. Just turn all the compressors off, let everything warm up, let all the valves open up, and just slam it all back on as fast as it can, and let all that velocity push all that oil that's in the system back up to the rack, and you just hope nothing explodes.
Well, think about it, Gary. Like if you don't have all that oil sitting down there, right? It's only going to come back with a high velocity, right? So if everything's at temp, right, and you just fucking shut it off and turn it back on, you're barely going to have any velocity come back because the expansion valves are going to meet it, right? But if you turn off the liquid line, pump down the whole system, have it shut down for half an hour to an hour, what's going to happen? Temperature is going to raise. So as soon as you open up that liquid line back up, the expansion valves are going to modulate, but they're going to be fucking wide open because the superheat's going to be high at that point, right?
Yeah.
So it's going to just fucking bring that velocity back up. So that one particular instance where I told you where they took the 40,000 BTUs off, basically what happened was that the guy would go there. He's like, man, I got 3 compressors that are down. I got no oil in the fucking separator. These 2 are basically just about to fucking shut off. What do I do? I was like, shut down the liquid line. I was like, wait for about, 45 minutes to an hour. All the temperatures rise up. Turns on the liquid line back up. Then all of a sudden he's like, well, I got oil back. It's coming back. All the compressors are filling up. Holy shit, And then the oil separator, because now instead of running just fucking 2 compressors, now we run 5 compressors. So what's going to happen? Now the separator is going to do what it's fucking supposed to do, unless it's a different issue, right? That's just with a helical. Now, if you have a coalescer, if you have an O-ring that's fucking blown or the coalescing filter is fucking impregnated, you're going to have to fix that. You know what I mean?
Yeah. Yeah. So I'm going to give you a way that we use, or this one particular machine that we did something similar with it. This was a 15-ton carrier condensing unit on a roof 5 stories above the evaporator. And we always had a lot of oil return problems with this thing because it had an unloader on it, mechanical unloader. So when it was in the unloaded position, obviously it's not moving as much refrigerant around and bringing the oil back. And we'd have oil failures all the time. And the way we would get it back is obviously we would get it to load up fully and sometimes have to block a portion of the condenser to drive the discharge up just to get that refrigerant moving. And then we'd eventually bring the oil back. We had to end up putting an oil separator on that one. And we also had to put an accumulator, suction line accumulator, because compressors kept getting banged up. These were 06Ds in there. Carlisles, they were getting banged up. Valves were getting crushed and everything. And this thing was problematic. And the way we fixed it was like oil separator and suction line accumulator. And even still after that, we were getting a lot of shit coming back. And it plugged up the screen and the accumulator. Then we were having oil return issues again because we couldn't get the oil through the accumulator at the bottom because that screen was plugged up with crap.
Damn, so that system was dirty as shit.
Yeah.
I've only seen one other accumulator plug, and it was on that CO2 rack. And let me tell you, that was bad. We were logging like 20 to 30 gallons of oil in this accumulator.
So, Gary, there's a post on the Supermarket Refrigeration Tech Talk. There's a page that I'm an admin on, and like basically there's like someone showed a picture of the sight glass, and it was fucking green. Yeah. It was green. And someone asked me, they're like, what do you think's wrong? I was like, it looks like someone put fucking dye in it. And then the background you could see of the picture the kid took, there was like fucking 10 empty cylinders. The kid pulled out 105 gallons of fucking oil.
Those were 2 of my guys. That
was it really?
those were 2 of my guys. It was an in-house store tech, and they were having case temp issues, and they were looking around. And he threw his gauge or a probe on a coffin case, and it was squirting out oil on the suction. And the call literally said, when you go there, you're probably gonna have to add 3 gallons of oil to the compressors.
That's funny.
This guy's been doing it for months. They drained out they filled up 2 55-gallon drums in the bed of a pickup. They were pumping it out they were draining it into 5-gallon buckets and then pumping it from there downstairs with a glycol pump into 55-gallon drums in the bed.
Wow,
that's for 3 days draining oil out of this thing.
Hold on, I have the pictures.
But we had a brand new accumulator. I mean, this was like a 8-foot tall accumulator by like 2.5 or 3 foot round. I mean, I think it was like a 600-pound accumulator, like full wise. We had one of those. The dip tube plugged up in it, and God, they still have not fixed it. It
Look at
was on 2 years now.
Gary, that looks like fucking dye.
Yeah, it was green just because there was too much oil in there.
That's all
Fucking
oil.
A.
Wow.
Hold on, let me bring up the other picture.
Like all the liquid was saturated with oil. Like at that store, like you pop the liquid line and it was just full oil.
So you can see. So this is before when they had when they first went there, right? And this is after removing 70 gallons, so it lightened up a little bit. And then 2 days after running 101 fucking gallons.
Man, this stuff like this happens in our trade all the time. I know, the stereotypical old school guy with his hand on the suction line. I've seen units overcharged by like 40-50% because they just keep going back every year and jamming gas in when there's a plugged up filter dryer, instead of finding the plugged up filter dryer, just jamming gas in it, and the things are going off on high head in heat waves in the summer. Right. I know one guy, he was yelling at the apprentices because he says they didn't clean the coils properly, but they were spotless, but he was jamming gas in every friggin' spring.
Well, look, like here. So this is what Kevin was talking about. So this particular system had a float on here, right? You can see all the fucking metal all up in here, right? So it blocked the friggin' hole, which didn't allow the oil to go to the compressors. So what does someone do? Jam some more fucking oil in the compressor. That's it. That's what you're supposed to do, right? So yeah, so
Crazy.
this is the end result. This is the amount of oil they took out the fucking system.
I wonder, I'd like to see the invoice trail for the oil that was purchased for this place.
Well, yeah, what POE oil right now is what? It's $140 per gallon. Is that what it is, Kev?
65.
Holy shit. So times that by 101 gallons. So they spent what? Like 12 grand? No, 106. No, 16 grand just on fucking oil, just to remove it. Right?
Well, then you got to dispose of it too. It's not like you're getting rid of a gallon or two. It's 55 gallon, or that's 110 gallons now. So, I mean, now you got to take it to somewhere that's going to dispose of it. You can't burn it like you could mineral oil.
You can still burn it.
No, you burn POE oil. It's nasty.
Well, so if you burn it, what you have to do is you actually have to dirty up the flame. So the polyol, whatever the hell is in there, it's synthetic, right? So it burns. It actually, if you burn that oil, it's very, very light. I used to do industrial compressors, Ingersoll Rand, and they used a synthetic oil. And so like we had an oil burner in the shop, and like I had this like literally dirty up the flame because the flame was so bright and light that the photo cell on the fucking oil burner wouldn't even pick up the flame. So the oil fell constantly. So I had to kill the air to it to make it actually work right.
So you're saying back in the day, people would take this a bucket of mineral oil and just burn it and get
Waste oil burner.
Really?
I used to work with this old guy. Like he used to do it in his garage all the time. I'm pretty sure he still does it with POE oil, but like it like obviously it's degassing refrigerant, and that's probably not good. But like,
gotta let it set for a little bit.
Yeah, I mean, a bucket like that is going to hold on to refrigerant for quite some time, right? Before it all boils out.
I mean, he'll burn it in his garage all day long in his like homemade oil burner.
Yep.
And is that heating his garage? Is he doing something productive with it, or just? Oh yeah, okay, all right.
Yeah, he's heating his garage with it. So in the wintertime, he has a waste oil burner that he like modified, and he runs refrigerant oil through it, or car oil.
Kev, you cheap fucker. I'm surprised you don't have an oil burner fucking burning mineral and fucking POE oil there.
My wife would not be okay with that.
You got insurance just in case. It's fine.
Yeah, interesting topic. Because I haven't got into oil separators in this depth of a conversation with anybody before. So very cool stuff.
Nah, man, it's weird. So like, there's so many aspects to refrigeration. Like, people most of the time are limited to like, oh, it's superheat and subcooling. That's it. there's so much more shit that goes into this. You know what I mean? And we just scrape the surface of, all the stuff that we deal with on the regular. Fucking some of the VFD shit.
Now, do you think this stuff is like? Do you think that things are being over-engineered nowadays? Do you think there's too much going into it and too much things that can break and too many problems that can arise? Because it's happening in the HVAC side too, where it's like, why did they do this much stuff to this machine?
Let me put it this way: my washer and dryer are the conventional front load and top load.
Yeah.
I don't go with the fucking with the front load both wash, because the more. I get it. Like, they're trying to be more energy efficient, but the more electronics is, the more stuff can go bad, right?
Mm-hmm.
I had a bitch of a time just shopping for a fucking refrigerator.
Yeah.
I mean, it's everything we work on, like all the CO2 stuff. They're pushing it all. Like, I mean, stuff's not where it needs to be yet. It's just overly complicated, too many safeties, and I mean, everything is just like they're overly complicating equipment that doesn't need to be overly complicated.
Yeah, CO2 is one of those things where you're basically, when we hit transcritical mode, you're basically manipulating the pressures in order to get the refrigerant to do what the fuck you want it to do.
Yeah.
And that's a whole other conversation. So sorry, but yeah.
That'll be another can of worms. Yeah. So I mean, I see it all the time on this end of things, commercial, residential, even like the heat pumps and the ductless. I mean, it's getting very smart. It's getting very efficient. I mean, for the most part, I see a lot of this ductless and VRF stuff being very reliable. And I've done a lot of VRF and I've done a lot of ductless through my career, installed it, serviced it, and I've seen it be very reliable on that front. I'm just wondering how it is in refrigeration. I know, like with when it comes to blower motors and stuff, with undersized duct systems that can cause more static with less airflow, we can heat up electronics more, like on an ECM motor and stuff like that. And we're seeing failures in that way. So I just don't know if you guys are seeing it on your side where things are failing because of the electronics involved these days.
See, we have the opposite. Like, we have the ECM motors going and everything, but they're submerged in water all the time, or they're cold, hot, cold, hot, cold. Every time they go into defrost, it's 85, 90 degrees, then right back down to minus 20. Constantly. So I mean, ECM motors, they've gotten a lot better. The older ones were horrible and didn't last long, and the newer ones, like, I mean, a lot of the rescue motors and stuff, those things are bulletproof.
So the problem is that you have condensation, right? If you're going quickly from a hot to cold, the dew point changes, and then basically you have a lot of condensation there.
Yeah.
And we deal with that in boxes a lot of times, because a lot of these, if you ever went into, I don't know what fucking supermarkets you have up in Canada, but like you have Costco's and BJ's and stuff, and a lot of times
we got Costco's,
yeah. So they have a lot of times the coolers that you fucking walk in. Well, those doors have to be set up fucking just perfect, because of the way the dew point runs. And what essentially happens is, if you take a wet bulb calculator, if you're running a saturated of like 18 degrees, right, and your dew point and your actual relative humidity in the box is like 50 degrees, your dew point is like 27 degrees. Well, if you're operating in an 18 degree saturated coil, that means it's 18 degrees. Well, dew point, right? What's the definition of dew point? Dew point is the temperature at which below the temperature will fucking start to condense. So if your coil's at 18 and your box temp it essentially has a dew point of 27, it's gonna, whatever surface that coil is fucking touching is gonna cause to condense, which causes liquid to drip off the bottom of the evaporator, which causes liquid to fucking form on the floor, and then people get pissed.
Yeah.
So there, I don't know. I don't know about you, but like, I know Kevin and I are real big numbers based. Like we what did you get for this? What did you get for this calculation? Like, we're constantly running shit back and forth with each other, just trying to figure out issues, right?
I mean, I don't use calculations that much in my line of work. It's because mostly what I see are electrical failures and not problems like you're speaking about with condensation coming off of apps and stuff like that. So, but I mean, I'm starting to deep dive a little bit more into that stuff, into a little bit more, because when you're in school and you sit there in class and they're giving you all these calculations and formulas, you're like, when am I going to use this in the field? Like, that's the attitude that most kids have. And I had it. I'm not going to lie, I had it. And now I'm seeing that the value in knowing that stuff and where and when to use it to find out what the hell is actually going on with a problem.
You don't need a license to do anything HVAC related.
So
That's interesting.
It was weird when I moved to Connecticut. Like I had I had been in the field for 8 years, but I had to go through an apprenticeship. So I went through one semester of HVAC school, and the instructor's like, "You got an electronics degree, you'll be fucking fine." And then I moved to Connecticut, and they're like, "You need to go through school." So I literally had to do like an online HVAC school in order to go through an apprenticeship. But I had been doing this shit for 8 years, and then I came to Texas, and they were like, "Oh, what's your social security number? Here's your fucking card." I'm like, "Cool."
Yeah. So what's good about that up here is every single province in Canada, as far as I know, they have a program that you have to go through. I think some even might be 4 years, but here in Ontario we're 5. But once you get that certificate, it's called a red seal, and it's transferable between provinces.
Well, that's like how kind of like industrial is. Like industrial, like if you're working on like ammonia, you have to essentially be an operator. So you have to go through the RETA classes and stuff like that. I know Jeremy Williams has a really good program that he does for his arts, his industrial program. But yeah, I don't know, man. Every area is different. It seems like the more unionized areas, require more. Like, so you're talking like big cities. So Chicago, have big unions, big union. Philadelphia or Philadelphia, whatever the fuck you want to call it. Jersey, New York. New York's a big fucking union state. There is a union here in Texas, but it's I don't know. I haven't touched it.
Yeah. Yeah, I've never experienced a union. I've always been non-union, so I can't really speak to what it'd be like to be in one. I just know it's a touchy subject when a non-union and a union tech get together and start bashing heads over that subject, right? It can get nasty. I've seen it.
I don't understand that. Like,
Neither do I. Yeah.
Someone asked Kevin when we first started doing the podcast. The guy's like, "Well, how do you guys work together?" Well, what do you mean? It's like, "Well, you work for different companies, and like Kevin's union, and you're not." I'm like, "So fucking
funny.
what, dude?"
Yeah, some people are. I don't know. That's the internet for you, right?
Yeah. So.
Anyway, guys, I appreciate the chat tonight. I gotta run myself. I am bagged. Like, I gotta get to bed soon. So I really appreciate your time and as far as the misunderstanding with that group, man, you can post there anytime you want. Like, I don't give a shit because I don't even go into that group anymore, really, because of how asinine it got with the trolls and everything. I'm like, I want to get rid of this thing. And I was telling you through messaging last night, you literally have to get rid of every single person in the group
to get rid of the group
and delete yourself last. And that's when your group is gone. And I'm like, there's no way I'm doing that. That's going to take me weeks to do that. I'd have to stop adding people in and then just delete a few every day. I'd be at it for days, weeks.
Well, no, and like I said to you before, like, I was like, because I talked about a year ago, when we first, started building up, I texted you, I was like, "Hey, Gary, do you mind if I fucking post to your group?" "Oh, yeah, whatever." And then I would post and then we get fucking denied or deleted. I'm like, well, what the fuck? You said I could. Like, what happened?
Well, I would guess that the mods that help me, the moderators, they probably are like, okay, well, he's got a podcast. He probably wouldn't want this podcast. That's the only thing I can think of. The only one I've told them in the past was a long time ago. There's a guy, I can't remember his name. He calls himself J Dub Moneymaker, I think. You heard of this guy?
No.
He calls himself J Dub Moneymaker, and he has a podcast, and he has these cheesy kind of posts that promote his training classes. He's one of these sell guys. You know what I mean? And he goes around the states and he holds these classes and he charges like $2,000, $3,000 a person to go to these classes.
I want to do that.
And but it's to sell. It's like that Grant Cardone.
Sell a contactor, sell a fucking, sell a new unit.
Yeah, it's sell. It's all about selling, no matter what the fucking problem is. Just sell them something before you leave the fucking house.
Yeah.
Right. And that's the only guy I told, and he calls himself J Dub Moneymaker. And you're recording this. You should probably turn it off.
All right, guys. Well, hey, listen, Gary, man, thanks a lot for being on, and have a good night.